Welcome to the first part of a series of short videos. The first providing concepts, providing background for a demonstration that will be used as a template for student solutions. This one, extending a file system for integrated enterprise solutions. We're going to use role-based access control. It's commonly called RBAC. Role-based access control. I'm Professor Timothy Kentop, and I work in the computer science department at University of the Virgin Islands. So here are some essential concepts. We will explore and explain the core concepts and requirements for RBAC and how OS file systems can be extended in an enterprise domain, Active Directory domain context. We're going to implement enterprise resources suitable for a team project using NTFS permissions, privileges, and inheritance. We're going to map nested directories to nested security groups and accounts to improve access and management. So there's going to be a one-to-one correlation between the file system resources and the security groups. We're going to apply best practices to integrate file level and share level security. And we're going to automate provision of resulting infrastructure with user logon. So, what are the essential concepts of role-based access? Well, let's talk about some things that are common practices that fall short, that undermine security. What role-based access, everyday practices in IT shops are not role-based access. So here's some things that are problems and why role-based access came about. So security principles are configured with tech jargon, and a common example would be there's accounting software that was developed for an organization, and their group names based on the application modules like fin2 underscore users. So as I talk through this demo, instead of calling out underscore each time, I'm just going to say that's in a placeholder where it's better not to use spaces. So, but anyway, fin2 users. So there's a second finance module in the application, and general users in the finance department, right? So one question this raises is, what do the users actually do and what can they access based on this group? You can't really tell. All you know is that it's the second module. Another problem that's a common practice that falls short and undermines security is that file system resources do not map clearly with security principles. So the second module may have a directory that has nothing to do with fin2 users. It could be some subdirectory that doesn't really track with this, and that becomes confusing. Individual user accounts, this is the worst. So we saved the worst offense for last. Individual user accounts are used directly to provision access for a resource. When assignments and roles change, it's very hard to manage, and we'll give you some quick examples of that later. So an example in context is the best way to provide clarity and contrast. So let's take two scenarios, one that's poor and one that's good. The first one, the poor provision of resources. So suppose finance staff performing an accounts payable role using fin2 user, privileges and permissions, is promoted to another section of the finance department, the accounts receivable team, right? And let's say they're a team lead. So they're also going to use the group fin3 manager. And why are they going to do that? Well, there's transition when somebody's promoted. So the sensibilities that kick into play until replacement AP staff can be trained. Let's face it, the routine invoices, the bills, must still be paid. The new AR manager must also be trained to learn management functions in the area. So they have to get new access to train, but hey, somebody has to pay the bills in the meantime, right? The problem is that since software security groups recommended by the application developer are derived from a programming perspective and not based on the local context for the roles and assignments, right? Neither the finance nor the tech leads perceive a problem if a user is assigned to both fin2 user and fin3 manager. It looks like, oh, they just have more access to more modules, but they're moving up and there's some transition. That's normal, right? They don't really connect the dots. They don't really see the problem. Okay? And it is a big problem. It is a huge problem. It is a mother of all problems. The practice violates accounting principles, and in most cases, fraud results. So it would be cause to fail an audit if this were discovered, right? This is serious stuff. Scenario B, best practice, right? So let's take the same scenario and apply role-based access control. Suppose the tech team devises security groups with sensible names that reflect the role that's performed based on that access. What the individual is doing when they're a member of that group, that security group, right? So in this case, we're gonna drop the use of fin2 user, and we're gonna assign that staff member to the first group that's called accounts payable staff. So now we know what the second financial module users are actually doing. They're paying bills, they're receiving invoices, and they're validating payments out to keep the wheels turning, right? So that's what they're doing. The fin3 manager is dropped, right? And instead the IT department's going to adopt a security group that's called accounts receivable supervisor. So they can basically designate incoming funds and revenues for a certain bank account or for a certain general ledger account, right? They supervise incoming funds, right? Now, when the security principles for the promoted individual are reviewed by either finance or tech leads, since the user has both assignments based on a role, what happens is that they see, oh, wait a minute, if they're a member of this group and a member of that group, it means they can take money in and they can pay money out. Ding, 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 ding. Ooh, that's a problem. The conflict of interest, the violation of generally acceptable accounting procedures, or GAAP, right? Those standards, the violation of GAAP standards and a fraud risk is plain. Somebody says, oh snap, they can take money in and they can write checks out. What keeps them from taking money in and funneling money back out to themselves or their friends? Okay, so based on that, when somebody looks, they can see accounts payable and accounts receivable. Oh no, that's a no-no. So alternate access can be staged in phases to prevent the fraud. Now here's a point of order for tech staff. Many tech staff might argue that they cannot control what software developers require for applications to function. So if they recommend a certain breakout for security groups, when you're installing software, they're just doing what the developers told them to do. This is inaccurate. Active Directory NTFS environments allow security groups to be nested inside other groups. So what does that mean? When the software is installed on a system, the developer's specified groups and accounts can be used to deploy the solution. However, when the access to the solution is provisioned to users, role-based security groups that plainly reflect the responsibilities can be embedded inside the application security groups. It can be nested inside those other groups. So the local context can be managed by the leads in those departments and in the tech department, right? So here's a related question. Suppose the user assigned a role is the only one performing the role. Should a security group, right, which is normally thought of as two or more, do you create a group when there's just a single user? Wouldn't it be easier to just simply work the assignment for permissions with the user account directly? So I'm going to answer each question respectively. So let's answer the first question. Should a security group be created for a single user? If you're going to do role-based access control, yes. You cannot map an explicit role to a group or to files or related file system resources without it. Can't do it. Right? So you have to do it. Yeah. And it may seem like extra work, but it saves so much work later. Now, wouldn't it be easier to simply work the assignments with the user account? Oh yes, it would. It would be easier. However, an account maps to a user identity, not to a role. You're saying, so what? So groups have to do with roles or projects or whatever. It has to do with functions and responsibilities, but an account has to do with identities. Why is that distinction important? What a person can do with their access becomes obscured over time if their identity becomes directly associated with the directories and files that they access to perform their roles. And to see that, we have to take this a little further. So let's take the worst case scenario, and I'm gonna say this is worst case, but that's tongue-in-cheek. It's actually a pretty routine case. Let's say an employee is promoted multiple times, right? So here's a quick example of how bad it can get, right? Suppose a person starts out as an HR receptionist, then becomes payroll staff, then a finance department lead, okay? So 18 months, 2 years as an HR receptionist, so they have potential, you know, they're responsible, they're ethical, they've done good job working with personnel when it comes to integrity, so now it's safe to put them in payroll. So now they're doing a payroll function, and then we move them after a couple years in payroll staff, 3 years in payroll. Now they're in the finance. So within 5 years, they've advanced to a third position, and they're up. They're climbing the ladder, right? Now they're a finance department lead. Could be one of the subdivisions within one of the subdivisions in that department. Now, just for the HR role, there are dozens of directories and over 100 files just for the HR work, right? Including policy files and references for that HR, that daily routine in the HR department. And if those are provisioned with user account permissions, that means the name of that user account, their name is tagged on all of those resources. Not a role, but their name directly. And let's say that some of their names, well, the name of that one person is on some of the other project directories and HR department subdirectories, okay? So just in their own case, and then for the department, their name, their user account is associated with hundreds, you know, just hundreds of file system objects, right? And then let's look at what happens when they go to payroll. Repeat the same thing, right? So now they have, let's say they move to payroll, and now there are dozens of directories, hundreds of files, and of course projects going on in payroll and other subdirectories and other resources in payroll, and then repeat it again within that 5-year period while they're a lead for finance. So why is that an issue? You're still saying, I don't understand why that's a problem. If we were using a security group instead, you'd have that security group tagged, and that would be in hundreds, literally hundreds of places on all these systems and servers. We'll let the other shoe drop in just a second. So here's the missing detail that most don't realize until it's far too late. Both security and those that have to make sure systems are secure, cybersecurity professionals and IT staff don't realize this until it's too late. So the sysadmin screens display which groups a user account utilizes. That's what they have to reference. Okay? It does not show a comprehensive listing of directories and files. An individual user account is assigned, or all those directories and files are tagged with that individual name on one server versus another server for multiple resources across the domain. So now you have a person's explicit name in there, and it's on all those things as opposed to a role, right? So how would RBAC change the scenario, right? Well, if the resources were only provisioned using groups, when you drop an individual login account as a member of that group, it removes their access everywhere. Automagically. They no longer have access, and all those hundreds of references on all those systems and applications, they don't. You made one change. You dropped their user account from that group. So all of the associated permissions, they no longer have access to. The group does, so their replacement gains access when you add them, right? It's just one change, and wow, it just propagates across all these systems and all these applications. It's huge. Now, there is a single exception where the direct use of a security account, an individual account, is sensible, and that's for the provisioning of general purpose storage for what we would call a home directory. So the only time that direct use of an account to assign permissions with directories in an RBAC scenario is okay is to provision a home directory, or H drive, to an individual for general purpose storage that is designated for each user. So as this individual moves from HR, in our example, to payroll, to a lead in the finance department, they may keep copies of some of the work that they did, but it's historical record from 2 years ago. But they don't have access to the same stuff in payroll or in HR anymore, and they shouldn't. If they're a lead for a different department, why would they have access to HR records for everyone in the organization? You see, if they have an H drive and they basically keep copies of their work for reference so that they have, and that's appropriate, right? You can keep records of your own work history. That kind of record is fine, but the contents of the H drive are going to evolve and change as the person evolves and changes. That doesn't mean that they get to go back in time and have access to everything else. So in this case, the term general purpose storage, the important point here is that it is not associated with a specific role, project, task, or team, right? It's for the individual. So in that case alone, can it be assigned to an individual account? So just to be clear, we're always going to create a security group that maps to a specific role performed, or project, or team, or discrete set of tasks, like AKA responsibility. That's what you would call a responsibility. We're always going to map file system resources, directories and files, that are required for that role to a group, to the group, which has a like name. We're going to use like names for the directories and shares, the file system objects. Not just the security principles, but the file system objects. They're going to use like names. If possible, identical names, right? And here are the benefits. So a processor security gap becomes obvious. Consider the previous example. The same user cannot receive funds and then dispense funds. And that's the case we just examined. All it took was a single move and Armageddon, right? Except nobody knows. Nobody sees it plainly. So what's the benefit? Everybody sees it plainly. They can manage more effectively. All right, for this demonstration, we're going to be using generic group names and account names. You'll see in a minute. So for students, instead of using actual student names and using actual groups, we're going to be using notional student names, student 1, student 2, student 3. So for the demonstration that you're going to watch in the next YouTube video, in order for that to work right, you need an Active Directory domain to provide a scalable environment. We have that in place. You're going to need separate systems with remote access configured for each student or participant. So as you work your solution based on the demo, you're going to follow the demo to perform your solution. You have access to your own system. You won't screw up anybody else's Kool-Aid. Right? DNS is configured with host names for interactive operations. Right? So in this Active Directory environment, the host names are plainly a part of an FQDN convention, right? Fully qualified domain name convention, so the host names can be resolved. And participants should possess an understanding of basic OS concepts. For example, privileges via security principal designations like user accounts or the super user group or owner designation, right? So privileges are rendered by membership in security groups and for security principal special security principal designations like owner. And then permissions that are assigned to the file system objects, directories, files, and shares like read-only and modify, and then inheritance. the propagation of those settings from a parent directory to child objects. So what we're really talking about is recursive application, right? Into the path. It propagates down into the path into all the subfolders and or subdirectories and subdirectories. In Linux, we would call this a -R switch, right? And in Windows, it's called inheritance. The context for this demo. Let's talk about the context. We want to provide a sensible, robust file system that offers resources to students enrolled in a single course that are working on projects on 2 rival campuses. So we have the course as a whole, but then we also have 2 separate sites, and they're rivals, so they have to have separate provision of file system resources so they can't get into each other's Kool-Aid. Each campus has formed a team for collaborative software development, and they're in competition with each other. So there's a team on St. Thomas and one on St. Croix. The grandparent directory for the course provides a read and execute resource for all students in the course. 2 parent directories provide a read and execute resource for only students in a given team. So on the parent level, we're going to call that the site directory. It's only going to provide read and execute resources for students in that team. Only St. Thomas students can see what's in the St. Thomas folder. Only St. Croix students can see what's in the St. Croix folder or directory. And then there are 6 grandchild directories. We call them grandchild. So grandparent, parent, grandchild directories provide modifiable storage for each student he or she owns. Now this home folder for each student is viewable by their own team members. So they can see each other's stuff as they develop modules for coding. Their partners, their team members can see what they're doing with the module code. So as they're doing their components, they have a common reference, right? It's very, very robust structure. So the group account and related designations we'll need for this. The main security group for the course is CSE_444, and that's going to map to a CSE_444 directory. 2 smaller groups for the course, security groups, are team_STT and team STX. And then 6 user accounts, student 1, student 2, student 3, student 4, student 5, student 6. The first 3 students reside on St. Croix, the last 3 on St. Thomas. So student 4, 5, and 6 are on St. Thomas. 1 student on each campus is designated a moderator role, a lead role. So that's how we're framing this. They are assigned a role, and as those roles change, all we have to do is change the membership of the role security group. It allows each lead is allowed to post material in the site directory. That moderator role or lead role also provides privileges as opposed to permissions because they are assigned as owners of that site directory. And that's a separate security designation, but it's not like read, write, execute, but it's a way to control access based on membership, right? And designation. So owner designation. Directories match the security designations. The user directories are nested within respective site directories. So each site directory has the user directories nested within. Both site directories are nested in turn within the course directory. Just as user accounts are only listed in the site security group, only the team and site security groups are listed in the course group. There are 2 exceptions. The first exception, the instructor role is listed in all groups and possesses modified permissions. So the instructor can post information into the course directory or each site directory because they're the instructor, right? The second exception, neither the team leads nor the instructor roles are listed in each of the user home directories. This will prevent a case where one of the students say, oh, my teammate is student 1 and she hates my guts. We used to date and I had stuff in my directory but now it's gone and she's the team lead and she doesn't like me anymore, so she's in my Kool-Aid. That's why I can't do my stuff today. And we're going to prevent that because neither the team leads nor the instructor, right? No student's going to be able to say, well, the instructor is out for me. So I had stuff in there and now it's gone. No, the instructor roles don't propagate. They do not inherit into the user home directories. It's going to be physically impossible for the instructor or the team leads to muck with the Kool-Aid of each of the users, right? Wonderfully robust, granular control. All right, so a view of the folder and the principal organization, right? So here are the directories shown in File Explorer. You have a CSC 444 main folder, the two team folders, and they're shown on the right pane here. This is just an exploded view, right? And what are we saying? We're saying that the STT lead role, that's a group. It's a security group. It's not a user account. It is a group. And one of these, student 4, student 5, student 6, one of these 3 students on St. Thomas will be listed as a member of the STT lead group, and that's how they are provisioned permissions, appropriate levels of permissions for the team STT folder. Same is true on the team STX side. The STX lead security group will have a single student listed in the STX lead group, and because of that, the team folder, they'll have the proper permissions. Now, if they develop other resources, directories, and so on, if the leadership changes, all they have to do is switch out the students that are assigned to the STX lead, and voila, we're done. We don't have to go in there and try to figure out, okay, which student, where is student 1 listed in all of these subdirectories inside this team directory? I don't have to do that. I have to go on a search and destroy mission. Nobody has time for that. So, essential process. Let's review. Whenever inheritance is applied to an enterprise resource, you click. All right, so in terms of the actual interface, here's a view of what you're going to see in the demo and then what you're going to work with in your solution. You click here to disable the inheritance from the parent directories or upstream directories. In this case, you see users are listed for read, execute, and special, and that's inherited from the root of the E drive. We're going to disable that. We're going to get rid of that. We can't get rid of that unless we disable inheritance, because that setting is forced down into the folders we're setting up, the directories we're setting up. We're going to click on a different one. So we're clicking here to disable inheritance from above when we want to turn on inheritance so it propagates into the child and grandchild directories. We're going to click there, down here. There's a checkbox below the disable inheritance option. So this one stops inheritance from the upstream parent directory. This one pushes current permissions down into child objects, subdirectories, and other files below that. So that's what it's going to look like in the solution. So now you know what to expect as you move in, as you view the demo and then start your own solution. As you practice the solution, here are the benefits that we're going to have for the rest of the course. All the students can reference common course resources, right? Team members can reference common site resources. Rivals cannot reference opposing sites or opposing user directories. Students can readily reference work and resources of their peers. Each student can publish his or her own work intuitively. Changes are quick and easy. You can change a group and drag a folder and you're done, right? And most importantly, when we finish this solution, each student will build their own server out with like folders, directories, and so on, all the groups. When they finish building that system, they're going to be able to build separate. They're going to be able to use that as a platform for different solutions, and as they log into each other's systems, their resources will follow them as they go. So the network shares that we configure after the NTFS permissions are set, as they log in on these different systems, they'll have consistent drive maps. G drive letter for group, that would be the site folder. S drive for solutions, and the H folder for their own home directory, right? They're going to have these benefits. So this concludes our review of our concepts. Please start the next part, which shows you how this actually works in a demo. Again, that's the reference that you're going to use. You can follow along when you build your own solution. Thank you for your time. And after a short break, check out the next video.